Hi friends, welcome to my YouTube channel. In this video, we are going to see organic chemistry, some basic principles and techniques, part 3. Already I uploaded part 1 and part 2. You can check those videos in the playlist Organic Chemistry with Tricks. Okay, so let's start the 10 points for today. The first point, acyclic or open chain compounds. So they are also called as aliphatic compounds. Okay, now I'll tell you what are acyclic or open chain compounds. So first of all, open chain means that they do not form a closed structure. Okay, so open and closed are basically the opposite words. So open means no closed chain or a ring. A ring structure will not be present in these compounds. So the compounds which do not have ring structures are called as acyclic or open chain compounds. You can see them as straight or branch chain compounds. Straight chain compounds example is ethane. So any alkane. Okay, so if the alkane is present in a straight chain, then it will be a straight chain. It will be considered as a straight chain. Now, what is branched? Branched means, for example, you can see isobutane. There is a straight chain which contains 3 carbon and the 4th carbon is branched. Okay, so I hope you understood what are acyclic or open chain compounds or aliphatic compounds. Now, let's go to the second point. Alicyclic or closed chain compounds or ring compounds. Earlier we saw open chain. Now we are going to see closed chain compounds or ring compounds or alicyclic compounds. Be clear with the names. Okay. Now we know two different words. Homo, hetero. Homo means same or similar. Hetero means different. Now the carbon atoms joined in the form of a ring. When only the carbon atoms are present in a ring, then it is known as homocyclic compounds. When carbon atom plus some other atoms are present in the ring, it is known as a heterocyclic compound. You can see the examples for homocyclic as well as heterocyclic compounds over here. Cyclopropane, you can see 3 carbons which are in the form of a ring. Now cyclopropane is a homocyclic compound because it contains only carbon. Similarly, cyclohexene, it is a cyclic compound. 6 carbons are present. Hex and ene, there is an alkene group, right? There is a double bond. So that's why this is called as cyclohexene and only carbon is present. So it is also a homocyclic compound. Now coming to heterocyclic compounds, tetrahydrofuran. Now this compound you can see one oxygen is present in between the carbons. So some other atom other than carbon is present. So this is called a heterocyclic compound. Its name is tetrahydrofuran. Okay, please be clear with the name. Alicyclic compounds exhibit some properties similar to those of aliphatic compounds. Let's go to the next point. Aromatic compounds. Benzene, which is C6H6, and other related ring compounds are called as benzenoid compounds. Now coming to aromatic compounds, benzene, which is C6H6, and other related ring compounds are called as benzenoid compounds. Okay, this is enough about aromatic compounds. Now let's go to the benzenoid aromatic compounds. You can see benzene, which is C6H6. Then there is aniline, which is C6H5NH2. Then there is naphthalene. 2 rings are present in naphthalene. Okay, with that being said, let's go to the non-benzenoid compounds. What is a non-benzenoid compound? Before telling that, I'll tell you what is conjugation. Now, you can see towards the right of your screen, there is a single bond, then there is a double bond, then there is again a single bond. Okay, I've just highlighted it with yellow color. Hope you can see that. I'll just draw an arrow for you to see that. Okay, now this is called conjugation. What is conjugation? In between the 2 single bonds, you can see a double bond. I have marked with an arrow also and I've also highlighted. Okay, please see that. There are 2 single bonds, right? And in between that, you can see a double bond. Now this is conjugation. But in the compound tropolone, okay, you can see there is a single bond. I've just written the word single bond. And there is a double bond. And here, 2 arrows I marked. You can clearly see there are 2 single bonds together. Now this is a place where 2 single bond gap is present, like double bond, double bond. That is not conjugation. So it is a non-benzenoid compound. The compounds which have conjugation are called as benzenoid compounds, and the compounds which do not have conjugation, like this, tropolone is an example for a non-benzenoid compound. I'll just explain it in short again. What is conjugation? When there are 2 single bonds and in between the 2 single bonds, if there is a double bond, then it is called as conjugation. Very simple. So it is like single bond, single bond should be present together. Single bond, double bond, like this. But in this compound tropalone, you can clearly see there are two single bonds and in between two double bonds. So it is not in conjugation. That's it. Let's go to the heterocyclic aromatic compounds. Now, heterocyclic aromatic compounds like furan, thiophene, pyridine have carbon plus some other atoms. So, they have different atoms and they are also aromatic. So, we call them as heterocyclic aromatic compounds. I hope that is clear. Now, let's go to the homocyclic aromatic compounds. Only carbon should be present. Okay, now let's see. Now, you may ask me, is aniline a homocyclic aromatic compound? My answer to that, yes, it is a homocyclic aromatic compound because if you see, aniline is basically C6H5NH2. I've drawn and shown you. There are nitrogen and hydrogen in that compound, but then they are attached to a carbon and they are not directly a part of the ring. Now we are talking about the atoms which are directly a part of the ring. Okay, so that is benzene. Basically you can see I have highlighted in green. To that carbon NH2 group is attached. That is aniline. Okay, one of the hydrogen is replaced by NH2. That's it. You should find and tell me whether homocyclic aromatic compounds have only carbon or carbon and hydrogen. Okay, just find out and tell me. Functional group. What is a functional group? Basically, a functional group is actually responsible for the characteristic chemical properties of a compound. What are chemical properties? What do I mean by chemical properties? Find and tell me in the comment section. You can see some functional groups in the 9th point. Hydroxyl group OH and aldehyde group CHO. Find and tell me what is carboxylic acid group in the comment section without fail. Let's go to homologous series. Members of this series can be represented by a general molecular formula and the successive members differ from each other in the molecular formula by a CH2 group. Examples are methane, ethane, propane. You can clearly see, I'll explain it again. Homologous series are a group of compounds, like there are many members for this series and they are represented by a general molecular formula. For example, alkane, alkene, alkyne. You can say CnH2n plus 2, CnH2n, CnH2n minus 2. Like that, they can be represented by a general molecular formula and the successive members differ from each other in the molecular formula by a CH2 group. You can see methane, that is CH4. Next element in that series is ethane, right? 2 carbons are present in ethane. So you can see what is ethane. Basically you have CH4 and you have one more CH2. So that is ethane. That is the second member of the homologous series of alkanes. Next comes propane. You can see CH4, CH2, CH2. So, methane is the first member and propane is the third member of the series. You can clearly see methane and propane differ by 2 CH2 groups. Okay, I hope this is clear. Or you can also say propane as C2H6, that is ethane plus a CH2 group is present in it. So, it is called as the third member. So, it is propane and it is a third member of the homologous series. Can different functional group containing compounds be a part of the homologous series? Find and tell me in the comment section. Hope you understood everything which I said in the video and I hope you all would find out the answers for whatever I told you to find.